Lecture 6 Part 2 Iceberg ภูเขาน้ำแข็ง This show the brown color is the iceberg. Iceberg is floating on the sea surface, so we can write equilibrium equation. Weight of the W is the weight of the iceberg equal to buoyancy force Fb, and for weight is equal to rho density of the ice times total volume and time g. Okay. And buoyancy force is equal to rho of seawater times the difference between the total volume and volume of the iceberg above the water surface. So it means it's just gamma times the repressed water. And for the density of the seawater is about 1025 kilogram per cubic meter, and density of the ice is about 920 kilogram per cubic meter. So make the substitute in the equation 1 and make equilibrium, and g can be cancelled on both sides, and we divide the equation divided by the total volume, and we can prove that the delta volume divided by total volume is about 0.102. So it means only 10% of iceberg is above sea surface or sea surface. Okay. So in this case, if you watch the movie about the Titanic movie, for that time they don't know, they just see the 10% of iceberg above the sea surface. They don't see anything, didn't see anything below the surface. So why the boat can crash with the iceberg? Okay. The next problem is the density of the ball. If we have the ball put on the board in this figure, and for the density of iron is about 7,800 kilogram per cubic meter, and density of water is about 1,000 kilogram per cubic meter. The other case, the first case we put all the iron in the boat, and the second case we just put the iron in the water. So the question is, depth of water in first or second case is higher. H1 is greater than H2, or H1 is less than H2, or is equal. So in this case we have to consider about the displaced volume. So in this case we say that iron 1 cubic meter displaced water about 7.85 cubic meter. Okay, but in this case we say that the second case, iron 1 cubic meter depressed water just 1 cubic meter. So what we expect that H1 should be greater than H2. Okay. And this concept of the buoyancy force, we can apply this for hydrometer. Look at it. Okay, this is a hydrometer. We can use this instrument to measure the specific gravity of the fluid because of this tube is floating in the fluid. Okay, if density is high, so it means this floating will be this one show that it is a high density of the fluid, so it means the floating tube is to be moving up. So we can measure the density of the fluid using this hydrometer.